All right. So tomorrow's test, um, concepts, what you're going to need, um, understand acceleration, what that means. If something's experiencing accelerate, like a constant acceleration, how is something moving because of that? Direction of acceleration is a big concept that has a lot of pitfalls. Okay, don't fall into the, oh, it's speeding up, it's positive acceleration. Maybe, maybe not. Okay, so the direction of acceleration, it's an important point. So the direction of velocity and displacement is determined by which way it's moving. So if I'm going this way, I've got a positive velocity, positive displacement. If I'm moving this way, I've got a negative velocity, negative displacement. But my direction of acceleration not really determined by the motion, it's determined by the force. So which way it's being forced to cause it to speed up or slow down, that's the same direction of acceleration. Or you can memorize it from a, hey, if I'm going this way and I'm speeding up, so the sign of acceleration is the same as velocity. So if I've got negative velocity and I'm speeding up, I got a negative acceleration. Okay? If I'm speeding up this way, I've got a positive velocity, therefore, and I also will have a positive acceleration because I'm speeding up in that direction. Okay, so that's a thing. Oh, you're gonna see another use the metric system prefix chart because you need to know that how to do like convert. Like that was thought about that. I'm like, you know what? This is a hill that we need to die on. So like you're gonna get another one of those convert with the metric chart. I'll give you the chart. You convert it. You're welcome. Free points. Hopefully we get it this time. Okay. So you got acceleration, then you get to kinematic equations. So it's all multiple choice. So think how I'm going to make a multiple choice test. Like I'm going to like you're going to be setting things up. You could solve for some, but it's not going to be like the rocket problem. We have multiple parts. If there is something like that, then I'm going to like drop you in the middle of that. Like, here's this. What do you do the next step? Okay. Not all your accelerations are negative 9.8 meters per second squared. Okay, that's only if you're in free fall. If the object is touching something, if there's other forces acting on it besides the force of gravity, that is not free fall, and don't put acceleration at negative 9.8 meters per second squared. That is a popular wrong answer. Your fun facts of free fall. Velocity up equals velocity down, time up equals time down. Velocity at the highest point is equal to zero. Okay. Acceleration at the turnaround point is not zero because it's turning around, it's changing, the velocity is changing moment by moment by moment. Yeah. What do you study? Look over the lab, ask you a lot of good conceptual questions on that. Look at the PowerPoint. Make sure you understand why something is the way it is. You can change the question, modify that, because that's what I'm going to do on the test. I'm just going to take the questions you've seen, and I'm going to tweak them. Okay? Motion graphs. So acceleration versus time graphs are all going to be horizontal lines. I mean, I can like dance between that for an acceleration versus time graph. That's fair game. Okay. But acceleration versus time graphs will only be horizontal lines. Okay. velocity versus time graphs. So the slope of that gives you this. So and doing something like this, whatever, would produce that graph. So just like position versus time graphs tells you the slope of velocity, or sorry, the slope of a position versus time graph tells you the value of velocity. The slope of a velocity versus time graph tells you the value of acceleration. Okay, same relationship. Yeah. Good with that. On from the review worksheet, number 4, is that the soccer player? Will she make it? Question. Is that right? Okay. That had a little different flavor to it. So the way you do that is I've given you everything. Like you have a whole story. But then the question is this possible? Will she make it? Is this, something like that. So what you do is you make one of those unknown, solve for it, and then compare your mathematical answer to what the story is saying. And then you make a judgment call based upon, is that less than, equal to, or greater than what's given in the problem. So, for example, if you solved for time, I'm making these numbers up. Let's say in the story, her opponent's 4 seconds away from the ball, and you calculate her time to be 5 seconds. Like it requires her more time to get to the ball than she has, so she won't make it. So you're just evaluating that, or like you find that she needs a speed of like 8 meters a second. You calculate she has a speed of 7 meters a second. You're like, oh, she's not going fast enough. Okay, so you can solve for anything. You make a judgment call on will she make it or not based upon your math. Good. So that was a little different. I've asked quite a few times now. Hey, at half the time, what happens to, right? Probably one or two of those on the test. Okay. So then you got your expert TA. Good old online homework. Okay. Shit, question.
How many questions do you think they'll have to us?
Good question. There will be, okay, so
You still have to write it tonight.
do what?
You still have to write it.
There will be around 30 something questions, but there, so some of these are like quicker. Yeah. Yeah.
We're just waiting in power school.
What?
We're just waiting in power school.
Yeah. 55%.